In this video, I'm going to talk about force due to an electric field. I'm going to create a uniform electric field. I have two plates, a negatively charged plate on the left side and a positively charged plate on the right side. These oppositely charged plates will create an electric field directing from the positive charges to the negative charges. We have a uniform electric field pointing to the left. This is my electric field E. Direction is towards left, from positive charges to the negative charges. I'm going to place a small positive charge in between these plates. In which direction it will move? This charge experiences attraction from these negative charges or negatively charged plate and repulsion from this positively charged plate. It will experience a force towards left. Now, how do you find that force? We have this equation for the electric field. E equals force on a test charge divided by the test charge. So if you cross multiply this, you'll get force equals QE. And Newton's second law, F is net force is mass into acceleration. You can replace F with ma. You'll get this equation, ma equals QE, or acceleration of this charged particle is equal to QE divided by m, where Q is the charge of this particle, E is the electric field, m is the mass of this particle. In short, if you have a charged particle in an electric field, it would accelerate. How do we find the direction of this acceleration? Let's say I have an electric field pointing to the right, and I'm going to place a positive charge in this electric field. This positive charge would accelerate towards right or in the same direction as that of the electric field. So that's the direction of the acceleration of this positive charge. Now if you have a negative charge in this electric field, it would accelerate towards left in the direction opposite to that of the electric field. That's the direction of acceleration of a negative charge. A positive charge would accelerate in the same direction as that of the electric field, and a negative charge would accelerate in the direction opposite to that of the electric field. Let's solve a problem now. Electric field is pointing to the right. The magnitude of this electric field is 100 Newton per Coulomb. I have a positive charge in this electric field. It has a mass of 5 times 10 to the power of minus 8 kilograms and a charge of 6 microcoulomb, or 6 times 10 to the power of minus 6 coulombs. How do we find the direction and magnitude of the acceleration of this positive charge? Our electric field is towards right. A positive charge would accelerate in the same direction as that of the electric field. Now, how do we find the acceleration? This is the equation, F equals QE, where force is ma. So ma equals QE and A equals QE by m. Q is 6 times 10 to the power of minus 6. Electric field is 100. Mass is 5 times 10 to the power of minus 8. 12,000 meter per second squared.